Hey, physical science students, Miss Crowley here. So I hope you guys are doing good at home and hopefully these lessons are making sense to you. We are going to do a little review. So this is called a heat transfer and thermal energy review, Physical Science 2021. So our goal here is that you're going to show what you know about heat transfer and thermal energy. So here's a little practice. So the problem of the day is to match the example with the heat transfer type. So, conduction, convection, and radiation are the three types of heat transfer. So, if you look at the pictures below, so number one, the fire is direct contact with that frying pan, and the frying pan is in direct contact with that food. So, would that be conduction, convection, or radiation? And then in the second one, you can see the fire. So the light from the fire is moving out towards the dog. So is that conduction, convection, or radiation? And then the lava lamp. So the lava lamp where the there's a light at the bottom. So the light heats up the wax and then it moves to the top and it gets cold and then sinks to the bottom. So is that conduction, convection, or radiation? All right, there it is. So, number one is conduction because it's direct contact. So, when heat is transferred by direct contact, it's conduction. And radiation, anytime you see fire or light, microwaves, right, that is all going to be radiation. It can travel through empty space and it can transfer heat. And then convection in a lava lamp, because that happens in a liquid or gas, and the molecules near the heat source, which is the light at the bottom, heats up the molecules. They move faster, farther apart, become less dense, and rise. And then at the top, where it's cooler, then the particles move closer together, become more dense, and sink. And that just kind of keeps happening over and over again. All right. Now we have three more. Yep. So here we have boiling water. And you can see the arrows of the water moving up and then down. So is that conduction, convection, or radiation? And number two is where you have a metal rod and you put it in a flame, and then the heat is transferred to your hand where you are directly touching the metal rod. So is that conduction, convection, or radiation? And the last one, the sun rays traveling 93 million miles to the Earth through empty space. Is that conduction, convection, or radiation? And the answer is, drum roll, please. Right? Number one is convection because you get the convection currents. It's in a liquid because it's water, and the heat makes the molecules where the heat source is move faster, farther apart, become less dense, and they rise. And then at the top of the water, it's cooler, so more dense, and it sinks. And it just keeps happening and keeps happening so we make these convection currents. And then conduction, because you're directly touching the metal rod. The heat is transferred from the flame through the molecules in the metal rod to your hand, and you're directly touching it, and you can feel the heat. And then radiation, because the sun rays can travel through space to heat up our Earth. All right, I bet you got those all right. Yay. All right, so just a quick review. So convection, remember, because people get confused between convection and conduction. So convection has a V in it, and it means movement. So transferring heat by the movement of a fluid, and a fluid can be either a liquid or a gas. So the heat energy is going to make the molecules move farther apart. And because they're farther apart, it's less dense because you have less of them in the same amount of space. And so the hot fluids are going to rise because they're less dense. And cold fluids are going to sink because the molecules are packed closely together and so it's more dense and it's going to sink. So hotter liquids or gases are less dense and they rise up. It's not the heat that rises, it's the liquids or gases that rise up. And then cooler liquids or gases are more dense and they're going to sink down. Okay, so that is convection. And here's some examples. Your drink warming up. And you can see in the next one, you can see the convections happening because of the flame makes the molecules rise and then the cooler molecules at the top sink. And this is what's happening in a lava lamp, in boiling water, and it's how we heat our room. You put your heaters on the ground, on the floor. You don't put your heaters at the ceiling because if you put your heaters at the ceiling, all the hot air would stay at the top because the hot air rises, right? So it's going to stay at the top. So we put our heat source towards the bottom where the molecules get heated up. They move farther apart, they become less dense, and they rise. And then the cooler molecules sink. And this is how we heat our houses. It's how our atmosphere is heated. It's happening in the lava lamp and the boiling water. And I'm sure you've all seen boiling water. You can actually see it moving up and moving down. Okay, now we got conduction. Now, conduction has a D in it, so that's helps you remember that it's direct contact. So, transfer of heat within a material or between materials that are touching or in direct contact with each other. So, an example is a metal spoon that gets hot from the soup that it's in, right? Or here, if you see the metal rod, like we did that in the lab, where we could touch the copper or the aluminum and it got hot because the heat was transferred from in the lab, it was a hot water through the metal rod to your hand. So it's direct contact, and that's conduction. And we have some examples of conduction. Remember, our food gets cooked directly by touching the pan, and then the metal rod, heat travels up the rod, and we need to directly touch the rod to feel that the heat was transferred from the fire. And the spoon gets hot from directly touching the hot soup. So that is conduction. And last but not least, we got radiation, right? So radiation is the transfer of heat through empty space with no direct contact. The sun doesn't come to us and touch us and heats up our earth. The sun travels the light from the sun, the heat energy from the sun travels 93 million miles to come to the earth and then heat up the surface of the earth. It also heats up our atmosphere. All right. And you've all walked on like really hot blacktop, right, in the summertime. So you know, if you've ever done that, or really hot sand after the sun has been heating up, ouch, burns your feet. And then you also, I should have hid this the whole time. The heat you feel from the sun, a fire, heat lamps. So anytime you see light is or microwaves, that's going to be radiation. And here's some examples. So you got laying in the sun, radiation, feeling the heat from the fire. The dog's like, yay, it feels so good. Or using a radiating heater like we did in the lab where we had the space heater. So those are examples of radiation. Oh, actually, that's a light. All right, so now what you're going to do is you're going to go complete the heat transfer review. So you're at home, so you're going to upload that PDF to Notability, and you're going to do the first page has a heat transfer review. And then you're going to go to the second page and you're going to make a poster. You're going to make something, a visual poster like teaching. Like if you were going to teach about conduction, convection, and radiation, how would you do it? Well, you want to have a definition of each one of them. And then I want you to include two examples. So you can draw them if you want. So you can draw them, or you can find images to copy and paste, and Google is your friend. So you can Google images or you can draw them. And then when you are done with that sheet, you are going to upload your completed worksheet and take the closure review quiz in Schoology. All right? Does that sound good? If you need any help, where do you go? Well, we have office hours from 1:30 to 2:30 Monday through Thursday. And then we have office hours on Friday by appointment. So just email us and say, we need help. And we'll set up a time for you on Friday. Okay. So email Miss Ross or email Miss Crowley and we will make an appointment to help you out. Okay. So good luck. And then what we're going to do is we will do a Kahoot and we will have a quiz on this next Wednesday, Thursday. So we're going to learn about thermometers and how to read a thermometer and temperature on Monday, Tuesday, and then we will actually take the quiz on Wednesday, Thursday. All right, I hope that made sense. Good luck and have a great day.